For anybody's around, how are my audio levels? Too quiet? Too loud? I can adjust a little bit to make sure you guys can all hear. Okay. Is my oops, let me close this. Sorry, just getting started here. I'm gonna let people come in. Hey, what's up? Who is Red from the UK? How you doing? It must be very early in the morning for you out there, or very late at night. I don't know. It's pretty early here. I really need to get an additional tablet to put on my desk so I can interact more easily without interfering with what's going on in the stream. I do have a laptop, but I just don't have any space to set it up. Okay, what's up, Deader Than Disco? Okay, I'm gonna make a new document in this. Let's just call it design for now. What is technical design for now? Cool, man. Yeah, I'm really sorry. Unfortunately, just the way things work out, if I stream in the morning, Europe can't really watch at a decent hour. If I did the afternoon, it'd be fine. I just unfortunately rarely have space to myself in the evenings. So, and then yeah, of course, people out in the U.S. would be fast asleep. It's actually pretty late on the East Coast as it is. I think it's what, 9, 10 o'clock. I forget what daylight savings time ends up being. Okay, how many people we got in here? I can get started. Let me double check a few things. Okay, we got a few people in here. Oh, it's not too bad. 8 p.m. Cool. Okay, so you're 13 hours behind, effectively. What? Well, this is a good time. 9 o'clock my time. 9 a.m. Alrighty. So I guess what I'll be doing today is we're gonna do a little bit of tech design on this thing called a state machine that's gonna be controlling our characters in the game. So I'll just be diagramming that out just to visually demonstrate how we want things to work, and then we're gonna start implementing a parser, or just a processor for handling transitioning between states. Okay, so before I start doing that, I want to write a few key concepts down. So, what are the components of this character state machine? We're going to call it action state machine for now. So basically, we have actions, and these actions are singular. Well, these actions are unique, right? There are no two actions that are the same. A character can only say there are actions, there are actions. A character can only be performing one action at a time, which means we can't be walking and blocking at the same time. You can only be in one state at a time. So this is a particular design constraint of most 2D fighting games. You can imagine other style games that you can do actions while running, walking, like FPS. You can shoot while walking or running, all that kind of stuff. You don't stop, shoot, and continue running, right? In fighting games, you do. Like, you stop, you attack, you punch, you do whatever. You're always stuck in one state. And also, in general, an action state or just action will execute until the end of the action's animation. So this is mostly the case for attacks. We will only be running, or only be in the state until the animation for that action is finished. So we'll actually say this too. An action has an associated, an action has one or more animations that is played. So of course, when the character is trying to, jab, right? It will be playing just a jab animation. When the jab animation is finished, the character will do something else. We'll get to that. The other principle is most actions will return to the idle state. Now, this idle state may be standing, it may be crouching, it may be jumping, but the general idea is the idle state is something that you can transition out of to do other things. And we also refer to like this state as neutral sometimes. So the idle states such as standing, crouching, jumping, etc. Transition into let's say this state transitions into attacks and other actions. It's as to say commanded by the player. So if a player presses a button, the idle stance or idle state will go into attacks or movements and things like that based on player input. Okay, that's the general stuff I wanted to write down about that. So let's get a little more practical on this and make a diagram. I'm going to say concepts. Oops. Okay. Let's so basically we're going to think of the before I get into that, I'm not going to go over like what a state machine is. I mean, you can just go to like, Wikipedia, search for finite state machine. This is in Japanese, unfortunately. I should switch to English. Okay, there we go. I need to set my default language here. Anyway, yeah, you can just look up what a finite state machine is. I will be speaking about state machines informally, not sticking to the strictest definitions of what a finite state machine is. Hopefully, if you work on games or you are still in university or even before then, you have a little bit of idea what they are. So, okay. So basically, we're just going to diagram. Okay. Let's just say character FSN for here. So our start state is always going to be the quote-unquote idle state. Now again, this idle state might represent jumping, walking, whatever, or crouching. And in general, we're going to transition from idle to an attack, right? Whenever an input is pressed. So what we have here is the transition. And the transition is determined by, let's say, by input command. Will send us into an attack, right? So this is just going to be the high-level diagramming of what's going on. I'm not being specific about any attacks or whatnot. But we can also transition not only into attacks, right? We can transition into reactions. So whenever your opponent's attack volume, attack box hits you, your character is going to need to transition into a reaction. And reactions will be the same as any other action, where you're stuck into the animation until it's played out. And actually, you're going to have to be able to transition from both attacks and idle states on hit. So this is the kind of high-level view of the character state machine. We're going to get more granular here in a bit. But yeah, basically the whole character is going to work this way. I hope this makes sense, that these are transitions and these are states. Any questions about that? I'm gonna drill down a little more granular here in a second. Cool. So now what I want to do is do a little more detailed thing. So this is going to be a more general state machine still, but, well, not more general, it's going to be more detailed, but it's going to be a general state machine for all the characters in the game. So instead of saying exactly idle state, right, what I do want to do is, this is going to be important concept for 2D fighting games. These are kind of things that we've traditionally adhered to, right? So this is going to be our high-level, idle state, right? And we're just going to call this idle ground for now. The reason why I've made a block here is because I want to indicate that we can transition into a bunch of different states. So the first one is standing. And we're going to have, let's say, walking forward, backing up. Let's do this just to make it more clear what we're talking about. So this is basically going to indicate that when we're in our idle ground state, we're really in one of these four states. I want you to line this all up, right? Kind of make this a little bigger. Well, I want to make that bold and big. Make it pretty clear. didn't want that arrow there. So you're really in one of these 4 states. And from any of these 4 states, we can transition into a bunch of different states we're going to group together, right? Let's do this. Let's say ground attacks, right? So we can say like standing jab, standing kick. Let's say crouching jab. Oops. Crouching kick. And actually, let me go back here. I forgot to mention, this is a 2-way transition. Almost all of these. So I'm just going to write it with a different arrow. We could do a 2-way arrow, but I forgot to do this. Yeah. So once we're in an attack, and once the attack is finished, oops, I want to make a curve. Oh well, I won't make it a curve for now. So we're going to say on anim end to indicate the animation's finished on all these. It's not the prettiest diagram. I didn't want to make it curve, but these are just transition conditions, by the way. So let me put that in here, make it more parallel. And can I just curve it out? How do I want to do a curve. Can I do it with this? Oh, that's fine. That's fine. Whoops. So this is actually possible. Let's not talk about that particular right now, but let's just say it is possible to go from reaction to an attack. It's a very important concept in fighting games, but the devil's in the details. I don't want to overcomplicate things at the moment. Let's just say it is possible. So I can make them more readable. Anyway, yeah, so we can go from idle into reaction, and from reaction we go back to idle on anim end. Or we can say more like on hit stun end. Hit stun slash blocks stun end. So when hit stun or block stun is over, we go from reaction back to idle. Now this is just kind of a general case. So it's just a general case. Obviously, again, there are wrinkles in that. Okay, I think this is all correct. We can go from idle to attack, and the attack goes back to idle on anim end. Idle goes from reaction on hit, and it goes back on block, hit stun, block stun end. Okay. Anyway, let's go back to our detailed state machine. So we're going to have similar transitions from these, right? We're going to go from here to here on input. Let me go back. What do we say here? On input command. Let's say on input command, since this we consider it as a event or a condition. And then back the other way on unmend, right? Oh, I can't copy paste. Okay, that's lame. Let me copy paste that. Yeah, okay, that's why. Then of course we have another set of high level. We have the high level idea of reactions again, right? Oops. There we go. So we have reactions. So from any of these states, now it's going to depend on the design of the fighting game. I'm going to pull some stuff up later to demonstrate that, but in general, we can go from any other state to reactions. Hope you all can see this pretty good. So we can say standing hit, maybe crouching hit. We might be more granular here. We might have a launch reaction, launch, and then the knockdown reaction. This is just in the general case, right? We might have, we're probably going to have more. Oh, I say the right launch. Okay, and these are just kind of general reactions you would have in a fighting game. Whoops. And when those reactions are over, we will go back to this state, back to idle. When we say idle, what we're really talking about is returning to one of these states. That's the thing I just wanted to point out. We're not returning to an idle state and then going into walking or standing or things like that. That would incur potentially a 1 frame delay, right? If you transition to, say, an idle state and that took an entire frame to get there, and then another frame to go into either standing or crouching, walking forward, that would add a delay, which obviously not what we want. And it's definitely not how 2D fighting games have worked up to this point. Maybe there are ones out there, but yeah. You're right. Blocking is a reaction, so it's part of this. So let's just go put it down here. So standing block, crouching block, right? Let's just say guard, because blocking means something specifically in Japanese. So blocking in at least fighting game terms in Japanese refers to parrying. So I will avoid that for now, like using that terminology. So I'll stick to guard, so it doesn't confuse anybody. Okay, I'm sure it wouldn't confuse most people, but still. Okay, and on stun end, which could be block or attacking. And actually, so now that we're in the more granular point here, so technically, we can go directly from a reaction into attacks as well. So I'm going to write that out. Oops. So how do we do that? How do we go directly from a... So it's on stun end and on input command. I don't need these quotes. Quotes is kind of add confusion there. So once block or hit stun is done, and if you actually input something, you won't go to idle, which means one of these states. You'll go directly to an attack. This means you can get frame 1 attacks out of block stun. This is what makes frame advantage work the way it does. If you had to go through the idle state for 1 frame, that would basically be a -1. You have to subtract 1 from every frame advantage as a defender than you do right now, right? So the jumps are coming. Yeah, sorry. Just there's not a lot of space to diagram this stuff. So yeah, so jumps are included in this. I just wanted to point out this whole thing, right? Where we have hit goes to these reactions, and there's a bunch of other conditions that. So the thing to keep in mind is, yes, these are all reactions, part of like the same general concept of a state, but whether or not you go to standing hit, crouching hit, or you block, there's a bunch of different conditions for deciding which state inside of here you go to, right? It's the same with all of these, right? The input is what determines which attack. Not just input. There are other obviously other conditions, but yeah, in general, an input will occur and you'll go to an attack. A hit will occur and you'll go to a reaction. And when your stun is over, you'll go back to idle, or you'll go to attacks. Now, the important thing here is to show that since I was very specific about, let's say ground idle, to be symmetrical with this. But yeah, important thing to point out is you won't go into a grounded hit in general. Some games have this from from an air idle, like a jump, or an air attack. Now, some games, again, they have something called restand. That's very specific, right? It's a very specific state you go into. We could design the game to say if you're close to the ground, go into either a standing hit or whatever. But this is the general idea. I'm not sure if I want to diagram out the whole character state machine, since that's going to be represented in code and the details will change. But I wanted to point out, to avoid incurring a 1 frame latency, we transition from, and actually, one more important thing, not only do we transition directly into attacks from reactions or idles, but we can transition from attacks back into attacks. So on anim end, whoops, I'm going to make this prettier. On anim end and on input command. Okay. So we don't incur a 1 frame penalty by having to go, why did it do this to me? Oh, yeah. So we don't incur a 1 frame penalty by going back to idle first. This is a super important concept for making traditional fighting games. Yeah, it's incredibly important to understand this here. Okay. Conceptually, well, in practical terms, you could have multiple state transitions within a frame, right? You could actually go to an idle state and then go to an input state if there's input within the same frame and still have the same frame advantage. That's one way to implement it, right? But I'm trying to keep things simple as possible and without incurring additional bugs like subframe latency bugs. So we want to go directly into attacks from any reaction states, and pretty much any state will bring us back here. So just to make that clear, I'm going to come back here and diagram that back out. In the general case, oops, that shouldn't be folded like that. Let's see. What was it on hit? So this is a condition for going back here. Well, that's a different one. Let's say, oops, let's just re-edit that. And now we'll go there. Oops. Let's get rid of that. The arrows here indicate a transition from one state to the other. Transitions are atomic. You're either in one state or the other. And there's a condition. These are conditions for doing the transition, right? For example, we go from a reaction to an attack by inputting the attack command for that attack when the reaction is over with, which means on stun end. That signal or that event is fired when maybe a counter for your hit stun has gone to 0. All right. Okay. And then I also want to draw from attack to attack to make that clear. Oops. Make it prettier. Why should I make quick, pretty transitions? If there's any better tools, people let me know. But I'm very used to this draw.io. Oh. No, don't worry about it. I'm not trying to get I'm not really trying to necessarily get a lot of eyes on this Matt Knight. Excalidraw is good. Let me look at that. Let me bookmark it and come back to it. I'll check this off in my free time. But yeah, thanks for the link. Okay. Yeah, anyway, yeah, this is the general concept. And I hope this is mostly clear before we start getting into the actual detailed aspects of implementation. Who is rad? To be clear, for this game, we'll be doing one transition per frame. Technically, well, not even. Let's put it this way: there will be a stage for running the transitions that a player is in control of, and there will be another stage for handling reactions, because we want reactions to override any potential attacks a player has put in. The diagrams don't make that clear, unfortunately. I could diagram it all out, right, in that way, to show very clearly what has priority. These diagrams don't show priority, right? You see a transition here that goes on stun in and input command, and you see on stun in. So which path do you take, right? The diagram doesn't make that clear. In like a traditional or a more formal state machine diagram, you would have a transition into another, like a temporary state potentially, and then transition from that to either or, right? Giving a condition. But we have these one frame boundaries we're considering, so we don't want to introduce latency. Another way to do it would to be make a bunch of transitions that say, like, instead of saying on stun end here and on end and input command, or we'd have to do on stun end and no input command, right? And it just adds more complication to a lot of this. And I would have to start adding a, you know, and not everywhere. Yeah. But I'll include these diagrams in the documentation. Let me see. On the GitHub, if anybody wants to look at them. Okay. So, how much time we got here? Okay, good. We have about 36 minutes, 40 minutes on this. Okay, I want to start thinking about how we're going to actually implement. Hey, what's up, Kex IPS 06? I don't know how to pronounce your names. I'm sorry, Caxips. Okay, yeah. I want to actually get into how we're actually going to implement the state machines, right? So let's go state machines. Well, I was going to say the action state machine, and state machine processor, maybe. So this is going to be the actual code side of things. Well, before we actually do the code side of things, let's talk about the data. Okay. This is a action state machine data. So this is actually the structures we're going to use. So I mentioned before that actions are singular, they're unique. So we need a unique identifier, right? This is going to be something that's equivalent to a number, because numbers are unique, right? There's only one. There's only two twos. So let's just say the type is integer. Now, depending on what Zig lets us do, if we can come up with an enumeration, there's probably enums that lets us give unique identifiers. For now, we're going to hard code all our states in Zig code, not a scripting language or some kind of like data format or data in text format or binary format, whatever. We're not going to do that for now. We're just going to do everything in code. So we have a unique identifier. So pretty much all we need for the state itself is a unique identifier. Okay. And then there's going to be associated properties for each state. So this is going to include animation, hitboxes, sounds, things like hit properties, etc. Right? VFX. My current plan for hit properties is it's going to live on a timeline from 0 up into how long the state is going to last. Events like onAnimIn will fire when that timeline is over. Now there's going to be complications with branching and stuff that we'll get into, but for now, that's the basic concept. Okay. Now, there's going to be a code side of state, right? We might want to have custom behavior on a state when we actually transition and not use the general case, right? On hit, or go to reaction, on animin, go to idle, that kind of stuff. You might want to go from one state to another. For example, on something like a rekakin or like an ABC style combo, you would see a chain combo like you would see, let's say Fei Long. You can input a second special move while in the first Rekka and get the second Rekka, but it only comes out of that move. That would be a custom transition. Okay. So for now, let's just say custom transitions. It may be data, but in the future it may be code. We might make a general transition evaluator. So it's going to include conditions. Okay. So let's say we're going to have a condition and a state and target states. So we're going to want to have a condition that determines whether or not we go to another state, and then the state we're targeting. So for now, we're talking about the actual state machine processor. What does it need to actually do? Well, it needs to handle the actual transitioning. So it's going to have to look at the conditions for a transition for the current state, and then assign the character to the next state and do all the setup, initialization of the state. So checks transition conditions of the current state and sets the next state. And yeah, let's see. Let's just say that for now. A little early in the morning. I don't have a lot of caffeine in my bloodstream right now. This is just water. So it also needs, I want to say this must handle state setup, state initialization. Oops. And state teardown. So there might be certain things we need to do coming out of a state, such as if there is a sound playing on, say, a stand heavy attack, and that heavy attack is interrupted, you want that sound to end, right? This is just an example. It might not be what we do it here. You want that sound to end so it doesn't overlap, it doesn't continue playing into a reaction. And there's other things we want to do, like there might be invulnerable properties and it gets turned off or something. If you don't do that, you end up with things like happens in Capcom versus SNK 2, where you can carry over invulnerability from a role into your attacks, which is not great. These are like one of the things I do want to talk about is like I don't like implementing invulnerability as a variable that could be carried over because of historical problems they've had, like in CBS 2. The funny part is does Slayer, is that how Slayer works in Guilty Gear, or does he just have invulnerability during the backdash and it doesn't carry over? I think it carries over a little bit. I actually never looked at Slayer's code, so I'm not entirely sure. Okay. I think this is the basic idea we have here. Okay. So in practical terms, how are you actually going to implement a state in Zig? My guess for now is we're going to use enum. But unfortunately, the problem here is if we do everything in Zig code, enums are fine. We can always add a new state. But if we want flexibility in defining new states in maybe a description language, then that's not going to be sufficient. But at the same time, we do want this general state machine that all characters share, right? Like standing, crouching, walking, backing up. And we're going to want to identify those things in code so that we can be very explicit about how this works, right? Because most of it's going to work kind of the same. So the idea I think we're going to have to carry over is we're going to have an assigned type to each each action. So those enums won't be unique identifiers for in that case. Well, we could do it. We could have, again, C, I could do a lot of tricks with converting from int to enum and back. Say we could have the list of base states as enums, walking, backing up, crouching, jumping, etc., etc., etc. And then the integers after the last shared state, common state, would be unique identifiers for character-specific states, such as all their attacks. That's one way to do it. Now, I don't know if that's a Zig-friendly way of handling it. This is something I have to figure out. Okay, let's just go back to planning real quick. And so this is probably not going to be practical to do all today. So I'm going to have to split this stream up into 2 parts. Let's see. So what's a good starting point on this? Do we just take all states as unique or have common states? I are on the side of having common states, but, I don't know exactly how I want to implement this in Zig yet. So there could be 2 things, if certain characters' dashes are different, that's fine, right? We could have either, 2 separate common states, that's for run and step dash, and only implement those one of each, to the character. Or another way to do it is just not use common code. Maybe just implement each character's state entirely uniquely and have like maybe a shared utility function that handles the common case of run. And if they say one character is step dash, well, just don't call that code, right? This is if we were going to implement these states as script. Now, my goal here is to do most things in Zig, right? I don't want to start adding scripts because that's going to add a lot of complication to implementing this game. I think, yeah, if we end up having unique character states for like common states, I think we're just going to have maybe a unique source file or set of source files for each character. Because my goal here is not to make an engine, right? My goal here is to make this demonstration game. I'm trying to make a game, not trying to make an engine, right? You could take the code, or you can take the code as inspiration to implement your own engine if you wanted to. The concepts here would work as an engine, but that's not the goal here. The goal here is to make something practical that works, that demonstrates these concepts we've kind of adopted in fighting games for the last like 20 years, right? To show how those aspects are implemented. Not to make the most general engine that can be used for any kind of fighting game, right? If you want to turn this into a fighting game that's like is very different, you would have to take the source code and make modifications. So, before we go into like what we would do in Zig, let's just talk about and imagine what would be kind of the default way to handle this in other languages, right? If you're looking at C++, what would you probably do? Well, you kind of default to object-oriented programming here. So it means you'd make a class that has a state. And you'd probably implement a bunch of virtual functions or interfaces for updating the state. So anything you need to do within while the action is being active. You would implement maybe an onStart and onEnd function for each of those states, right? And you would do things like set the animation on start, maybe set up some properties, and on end you would like tear those down and whatnot. And then you would override those functions in a child class, and implement your own custom versions for each of your character states. That's something I don't want to do here necessarily. I expect most states or most attacks to use the built-in functionality, and only in exceptional cases will we need to implement custom code there. So we're going to add hooks for sure, but I don't want to use inheritance model. I hope that makes sense. Sorry. Okay. So in Zig, what is really our options here? Now, structs can have functions, but it's just syntax sugar as far as I'm aware. When we're talking about hooks for implementing the behavior of each state, especially the common states such as idle and such, or standing, crouching. One potential way of doing it is having a big switch statement and selecting on the state's unique identifier, basically just an integer enum, and then running the code for each of those under the switch statement. Now it leads to some very large block of code, right? So I want to avoid that, but that is one way to do that without invoking inheritance. And I was saying before, structs can have functions, but basically it's a syntax sugar for passing in the struct as the first parameter. And we did that, right? We did that, was it last time or a few times ago in our math module? We implemented this add function that takes self itself as the first parameter. It's something that is added by default if you call it on the struct. Oh, it wasn't here. That was in our game simulation, right? Yeah. So I don't know if there's any multiple dispatch kind of stuff, or just like what's the word for it? Well, I don't know if there's any like interface implementation where you can get any type being passed in as the first parameter, because we could consider having the code for each state, especially the common states, as its own set of its own set of functions that we need to call, right? Can we have function pointers in Zig? That would be one way to do it, is pass in a set of function pointers for the common states, and just implement those functions in their own source file, say the on start, on update, on end for say standing, and et cetera, et cetera, et cetera. Yeah, I think I read somewhere that Zig doesn't have first class functions, but I might be wrong there. Can you store functions in variables in Zig? Yeah, like does Zig have anonymous functions? Yeah. Thank you, Specs Guy. That's very helpful. Delegates. I guess you're talking about delegates from something like C Sharp. That's old documentation. Okay. We're on technically 0.9.0, but hold on. Yeah. Cool. Yeah, I'm sorry it's taking longer than I would hope, because we're trying to figure out the details of the mechanical aspects of implementing this. Okay. So just to test this out, it sounds like we could potentially have. Well, let's just use this as scratch real quick, okay? Because I don't want to implement a new thing. And actually, we got rid of this, right? This game object. We don't need this anymore. So let me delete that. So, whoops. I'm just gonna reuse this, to be honest. Let's say, I don't know, game state funcs. Let's say, whoops, action state funcs. It's not a good name for it yet, but sounds like we potentially have on start. Let's just say on start, on enter, on enter, and on start. And it doesn't really matter. Let's just do on start. And it sounds like we can have a type of. Let's say it passes in what we would pass in. Let's say nothing for now and return void. The simplest case, I guess. Could we do this? Am I missing something? So my idea is we can go down here, define this as vol. Let's just make it const test funcs. Make it the action start func equals dot on start we could assign this to. I don't think there's anonymous functions, right? There's no way to have an anonymous function. So let's just make a function here just to test this aspect of it. Test on start. I don't know what any of this is, so I'm just going to ignore it for now. Oh, I need to have the type explicit. Okay. And let's just say, is there a log? What is the log code again? Oops. Let's log. Oh, yeah, it's the state. Oops. Standard dot print f. Is printf is available? Oh no, that's part of C. Oops. I just want to get some output real quick. Oops. Console.log, what is that? Console.log. Hold on. What's the easiest way to log code? I don't want to use testing. I just want to log some stuff. Is it console.log? Is that a thing? That's a WebAssembly thing, sorry. Oh, thank you, Specs Guy, for saving me the effort. Okay. Okay. And then we don't need this, hopefully. It's optional argument. Okay. And so, does this work? Or do I need to make it a pointer? Could we do something like on start? Does that work? It still needs it on print. Okay, so you can't assume it. I got it. Oops. Needs an empty list. Got it. Okay, calling test on start. So that works. We could do something like that. Okay. So conceptually, we could have I'm not saying we want to do this, but conceptually we could have a bunch of functions that handle each of the transitions and, well, each of the events for a state. Conceptually, we could just make them expose functions like this. Like, I'm just going to spitball here. Not saying I want to do this, but for now, just for now, let's make a new folder just as an example. To say common this is called action states for now. Is it a file? I don't want to make a file. Actually, I want to make a folder. I want to make a folder. Let's say action states, for example. And then inside of here, we could just make a new file, standing state, or the standing state.zig or something. And then we could just have, function on start, void, whatever. We have to make this public, do stuff, pub, function on update, void. Yeah, this is just habit for me programming in other places. I'm sorry if there's a Zig standard for doing open closing brackets and I'm violating. I think there is. I apologize, but it's so built in my muscle memory of coding. But yeah, do stuff every frame. And then we could have stuff like, on end. And then conceptually, you could have, what is it? I just want to test this idea. This is not going to be the final implementation, but we could go up and say, let's just go to our game simulation. We could do like const standing state equals import action state slash standing state.zig. So, Rad, I've seen implementations that do return a state to go to after updating. And I did that. I actually do that in Fearless Night, but I'm not going to do that here. I'll get into details why later. But basically, I found that I had to do a lot of work to like. So if I needed to, if I wanted to transition in the middle of one of these um, um, like on update or something, there's some work I need to do that I need to like temporarily store in a variable, and then to check some more things, and then return what was stored in that variable. There's a lot of conditional stuff I had to add that was I felt like a little unnecessary and a little clunky. Okay, let's see. What are we doing on time here? It's a little past an hour, and I try to keep these pretty short. But this is brainstorming here. I would have to store this in, say, like something like here, right? In this, on update, on end. Again, there would have to be some kind of context I would pass into these functions, right? Such as like the game simulation itself would give me access in each of these to the whole state. Now I don't want to do that. We want to limit what each of these states can access in some way. But conceptually, yeah, you could get access. You could pass it the entire world state as a context, or the whole game simulation as context. Okay, this is not code I'm going to submit. This is just test stuff I put down on paper just to see what one way we can implement this. I'll put some thought into other potential ways to do this, and I'll discuss that next stream. But for now, I just want to leave it at that because we've gone a little past an hour, and I want to keep the videos at least digestible for people who come in later, and I probably should get to work. So, yeah, is there any final questions? Just let me know. While you all are contemplating that, let me just add this documentation changes to our source control. So, yeah. Let's go back to planning real quick to make sure. I don't want to do it there. I want to do it here. Where's planning? There we go. So we did take care of that. We haven't done that yet. So let's just put that as priority. We've kind of done this already. So let's just get rid of that. And go back to our okay, let's go back to our source control. Oops. What have I added? Oh, this doesn't actually include anything. Do I have to hold on? Do I have to go back to the diagram and save? Let's make, whoops. Is it going to save locally on my... Okay, I'm going to assume that is something that he can read. Okay. Let's add these. I don't want to submit any of this code, so I'm basically going to undo this at some point. Okay. Now let's just say updated documentation for character. Well, let's say okay. Let's just push that. And just double check everything's okay on GitHub real quick. Okay, there's not a view. Well, if you guys somehow can view that, let me know. I might export it as a PNG or something, or SVG later. Okay. I guess it doesn't seem to be any questions, anything like that. So I'm gonna go ahead and call it a day. Well, anyway, as always, thanks for coming by, and I hope maybe this was somewhat informational and helpful to your own endeavors. Well, until next time, if you have any questions, just put them on the back burner for me. And yeah, cool. Again, thanks for dropping by. Hope to see y'all soon. Good night, good evening, good morning, wherever you may be. See you soon. Bye.